have a different number 5 than everyone else. So I'm going to go over both number 5s because I don't know who has what. Okay. For number 1, because it gives you an equation and it gives you a set of numbers that are your domain, and asks you to find the range, you would need to take each of those x values, put them into your equation to find each y value. And then once you find each y value, because it gave us the domain and a set of numbers or a list of numbers, we have to give the range in that same format. So least to greatest without repeats. So our range would be, in curly brackets, -2, 0, 4, and 10. Another way you could have done this is if you put the equation y equals 2x plus 4 into your calculator, into Desmos. You could have made a table or gone to the table, found these in the calculator, you would have found these x values and then found what that y value was. In Desmos, you would have just made a table, put those x values in, and it would have computed the y values. Questions on number 1? For number 2, we're looking at each of these graphs to see, are they functions or are they not? So here you could have used the vertical line test to see if it touches more than one place. If it does touch it more than one place, it would not be a function. If it doesn't touch it more than one place, then it would be a function. So this is not a function, and these two are. Questions on number 2? Number 3, you need to find the slope. Remember that's your y2 minus y1 over x2 minus x1. So here, or if you switch them, as long as you switch 2 of them, you're good. This would be -2 minus 3 over -5 minus 2. So -5 over -7. The 2 negatives become a positive. So your slope would be positive 5/7. Questions on number 3? So some of you have this one and some of you have the other one, so we'll go over this and then the other one. For number 4, you need to find the x and y intercepts of both of these equations. I know it's been a while since we did intercepts, so I did this kind of fully. You would need to put 0 in for x or y and solve for the other, whatever's left. So here if we put 0 in for x, y is left, so we could divide both sides by -6, and we would get +2. And then we need to write our intercepts as ordered pairs. So this would be 0, 2. And then you can do the same thing for to find your x-intercept. Put 0 in for y. 3x equals -12 would be left. Divide everything by 3. And -4 would be your x-intercept. So -4, 0. Bless you. Bless you. Thank you. If you had this number 5 and you had to get r by itself, you would have needed to divide both sides by 2 pi. So your equation would be c divided by 2 pi equals r. If you had this number 5, you needed to move the 3x by adding it to the other side. Remember, when you do that, you're not actually combining these because they're not like terms. And then you're dividing everything by -3, so that this becomes a positive y, this becomes a negative x, and this becomes a -3. Do we have questions on 4 or 5? Before we get into our notes for today, I meant to mention something last class that I forgot, so I'm going to mention it now. So make sure everyone's listening. Take one earbud off or out. So at the end of the year, because this class does not require an SOL, that means unless at the end of the year, unless you have an A, you're going to be taking the final, which is worth 10% of your overall grade. I don't know much about the final except that much. Seniors obviously would be taking it before they graduate, but because it's worth 10% of your overall grade, those of you sitting at D's, that could make or break your grade. So keep that in mind moving forward. If that is the case for you right now, try to do better for the next semester or even for the rest of this marking period. That way you can bring that grade up just in case you need more of, I don't want to say this, but I'm going to say it anyway, like a buffer so that that doesn't really hurt your grade at the end. Does anyone have questions about the final?
Oh, so like, let's just say if you were to fail it, how many points would that go down? Would it go down like if you had like an A in your
You would probably drop down to a B.
Okay.
But that also depends on how badly you failed it.
Yeah.
When I know more about the final, you all will know more about the final, but that's the extent of my knowledge of that right now. If you have any other questions about that, let me know. If you haven't already, make sure you have these notes out. We're going to go ahead and start these notes. If your phone is a distraction, I would put it away or face it down.
Person?
So a lot of the stuff we do today, some of it's going to look familiar, like we talked about it before, but not in this way. Some of it won't look familiar because the wording is new. But keep those things in mind. Some of it will look familiar because we have talked about it somewhat, just not put words to it like this. So this new unit is on variation. And there are a couple different types. Today we're just going to talk about direct variation. So a direct variation is a specific relationship in which there is a constant ratio. And you can say this ratio is y over x between all ordered pairs. It's on the front here. Feel free in the unit 5 folder. Direct variation equations are written in the form y equals kx. That should look somewhat familiar. Teal crate. Thank you. With the unit 5 folder. Because it somewhat looks like it's in slope-intercept form, but it's K, not M. And here we don't have a B. So it's kind of like slope and slope-intercept form, but it's written a little differently. When we are looking for direct variation, all of the relationships between the numbers have to have some constant K. You might see it as constant of proportionality. It's also what it's called. To find this k, we're really using this ratio. So if I took this equation and I needed to solve it for k or get k by itself, I would divide both sides by x. So that's where that ratio comes from. So every time we do that ratio, we're really finding our constant k. So when we're looking for direct variation, we need to have a constant k, and it needs to be the same throughout all the points. Think about that like slope. When you move from one point to the next, it's the same as you move to every single point. Otherwise, the slope would be different. So for this, we're going to take that ratio and apply it here. So for this one, I have x, I have y. So to find my constant k, I would do 4 over 1, or just 4. So I could say that's my constant, but because I need it to be the same for all of these, I need to check them all to make sure they all work. If they don't all work, then that wouldn't be my constant k. So here, 8 divided by 2, that's 4. 12 divided by 3, that's 4. 16 divided by 4, that's also 4. So now I can definitely say that my constant k equals 4. Once I know my constant k for sure, I can write my equation for my direct variation. So it needs to be in this format. So it's going to be y equals my k value of 4 and then x. Before we continue, does anyone have any questions on how we found that or anything about that part? We're going to do another one. We're going to do 3. Same process. We still need to find our value of k. So when we do that, we have y over x, or negative 8 over negative 12, which would simplify to be 2/3. So if this fraction works for everything, then that would be my constant k. Negative 4 over negative 6 would simplify to 2/3. I'm going to come back to that 0, 0. And if I divide these to 2 over 3, it does give me 2/3. But if I divide 0 over 0, what would that give me? An error. So with that mindset, we would think, okay, k can't be 2/3. But before we continue with that mindset, look back at this equation. If this were the slope-intercept equation, what would our b be? I know that was confusing. Say that again. It would be 0. We don't have one. And that's something important that we'll need to know for direct variation equations. They will be written in that format, and the y-intercept will be 0. So here, I have a y-intercept. It is 0. It goes through the point 0. So I can say that even though my constant k wouldn't be the same right there, to get to that point it would be, and it goes through 0, 0. So I can still say this is a direct variation, even though it doesn't apply right there. The constant k doesn't apply right there. So my equation would be y equals 2/3 x. Do we have any questions on how we found that or why it's still a direct variation for that one? I want you to take a couple minutes and do 2 and 4, and then we'll come back and we'll talk about that.
Maddie, okay.
Yeah, I'm good. For number 2, what did we find for the value of k? Yeah. Okay. So when you divided y and x on each one, except for the 0, 0, you got -1/2. But because it goes through the point 0, 0, we can say this is a direct inverse. Direct variation is what I meant to say anyway. So y equals -1/2 x would be our equation. What was our k value for number 4? -3. You could divide each of these, so -15 by 5 is -3, -9 by 3 is -3, and continue on. So our direct variation equation was y equals -3x. Do we have any questions, concerns, any confusion about how we found those? Yes, Jake.
That's the negative one.
Yes, it does. Right. The next part. Now instead of given like a table of ordered pairs, numbers, or just ordered pairs, now we're given equations and we have to decide, are these direct variation equations or not? So we need to know what we found earlier, that it has to go through 0, 0, which means it would have to have a y-intercept of 0. Also, it has to be a line. So if you see something where it's like squared or cube, square root, cube root, absolute value, any of those, absolute value is technically 2 lines. Anyway, any other thing that's not in the form y equals mx plus b, then it would not be a line. So it has to be a line and it has to go through 0, 0. For number 5, would this be a direct variation? Yes. This is a line. The y-intercept would be 0. It's not given, but that would be 0. So I could say, yes, this is. And because it is, we now need to find our constant of variation or proportionality. What would our k value be? There's an S missing. What would k be? 3. Would 6 be a direct variation? Yes. And what would k be? -4/5. So this one looks a little different because it's a fraction, not a whole number, but the k can be a fraction. As long as it's a line and it goes through 0, 0, that's all you need. Would 7 be a direct variation? No. Because this one is going to be a horizontal line, and that's not going to go through 0, 0. So because it's not, you don't have to find the constant k, there's not one. For 8, we would need to solve it first. So divide both sides by 2. And then this looks similar to 6. It is a line. It goes through 0. So we can say this is. And the constant k would be 5/2. For 9, is that a direct variation? You're like, I'm not sure. Is it a line? Yes. Does it go through 0, 0? Is your y-intercept 0? No, it is not. So this would not be a direct variation. That's the easiest way to see. If it has a y-intercept that's not 0, it can't be a direct variation. Right? I want you to take the next, it may not even take me 5 minutes, to go through 10, 11, 12, and 13, and then we'll go back over this. Was 10 a direct variation or not? Yes. And what was our value of k? -1. When you solve this, I should have solved this already, sorry. You got y equals x over 2. Was this a direct variation? It is. If this confuses you, rewrite it. And now you can definitely see this is a direct variation. For this one, you can kind of already tell that there's going to be a y-intercept because you have constants. But solve it just to make sure. Would this be a direct variation? No. And then for this one, when we solve this, we get y equals -5x. Would this be a direct variation? Yes. And what would our value of k be? -5. Do we have any questions on how we determine if something is a direct variation from an equation? The next part of this is from graphs. So same rules, it has to be a line, it has to go through the origin. So if it isn't one of those two things, it can't be a direct variation. So for 14, would that be a direct variation? Yes. And if it is, we have to find a constant k. Remember, your k is like your slope, so we have to count our slope. What would k be for 14? 3/2. If we wanted to, we could write the actual direct variation equation, y equals 3/2x, but it's not necessary here. Is 15 a direct variation? No. It does not go through the origin. You can just check that. Is 16? Yes. And then what is that value of k? -1/4. Is 17? Yes. And what is our value of k? 1. Right? So as long as you know that it's a line and it goes through 0, 0, it is a direct variation. Right? The next part is really finding some missing values. So we're going to do 4 of these and then move on to some applications. So with some of these, like the ones in ordered pairs, well, really, we could do these a couple different ways. And we'll do 2 one way and 2 the other way. For this one, if you're given 2 sets of ordered pairs, you could either find your value of k, put it into your equation, and then solve for your variable, or you can set it up as a proportion. So we'll do the proportion way for this one and then the other way for the next one. How do we find k? What have we been doing to find our value of k, Jake? 1/x. To So that means if I'm taking that for both of these, I could say this is negative 4 over 2. And since I'm making a proportion, they have to be equal to each other. And this would be y over negative 6. I could solve this by cross multiplying. I'm going to rewrite this because my y's look like 4. This one is a y. This one is a 4. I don't know if that was better. So cross multiply. We could also simplify and then do that, but I'm not going to do that right here. So this would give us positive 24 equals 2y. Divide both sides by 2. And we can say that y is 12, which is what it asks us to find, the missing value. To make sure this works, the constant would need to be the same on both sides. So here we have negative 4 divided by 2, so that would give us negative 2. And if we put our y value back, we have 12 divided by negative 6, which would also give us negative 2. So our constant k is negative 2, but the question asks to find the y value, which is 12. So this would be one way you could solve this, using proportions. Before we do the other way, does anyone have questions on how we found that? Let's do 21. So now for 21, I'm not going to use proportional. I am in a sense, but not the way I just did it. Here, because I don't know this x value, I'm going to leave that alone for a second, and I'm going to focus on this part, 24 over 6, because I know to find k, I do y over x. So 24 over 6 will give me my value of k. And that would tell me that k is 4. I then know my equation would need to be y equals 4x. Now that I have that new equation, I can take the other order pair, the x and negative 16, and I can use those numbers. So I don't know what x is, but I know my y value is negative 16. And I can solve for x. It's like I used the proportion, but in a different way. I solved it kind of different. I could still double check to make sure this works. I could put negative 4 in here. I get negative 16. Or I could go back and do negative 16 divided by negative 4, and I get 4, which is the constant. So then you kind of have two different ways to check yourself. So I showed you both of these because you can choose. If you like the proportion way better, use that. Go ahead. If you like the method where you solve for k, find the equation, and then solve for the variable, do it that way. It's really your preference. Anyone have questions on either of those methods before we continue? I think it's okay, thank you. Today is the 20th, and Alright. Now let's do 22. So we'll do one way and the other. That way you get a feel for both, and then you can keep choosing whether you want to solve using proportions or solve using the other method. So for 22, instead of it being an ordered pair, they now tell us what x and y equals in a different way. If you were to get something like this, it would say whether it's direct or inverse variation. You'll see some of those later. So for this one, if we're using proportions, we could do negative 18 over 3 equals 30 over x and solve from there. Cross multiply, so we have 90 equals negative 18x. Divide both sides by negative 18. I don't know what that is off the top of my head. Someone do that in their calculator. Negative 5. You could double check. Does my constant k stay the same? Negative 18 over 3 is negative 6. 30 over negative 5 is negative 6. It stayed the same, so it works. For 25, I'm going to go back and do it the other way. So find my value of k first, dividing negative 7 and negative 28. That will become 1/4. Now I have my k value. I could put that into my equation. Y equals 1/4 x. For the second part, I need to find y, and now I'm given x, so I can put 20 in for x. And find what my y value is. This would be 20 divided by 4, or 5. I could check to make sure that my k still works. Here, 20 divided by 5. I'm sorry, I did that backwards. 5 divided by 20 is still 1/4, so my k stays the same. Mr. Northup, did you want to say something to that?
Which one of these is the K 1/2 or 2 over 1? And this, yeah, at this point, for $1,000.
1/2.
Which one?
1/2.
Is it 1 over 2 or 2 over 1? The K value. What is it?
1 over 2.
1 over 2?
Yeah.
Lily said that first.
Lily?
Yeah.
No, she did.
Yes, I did.
Yes.
1 over 2? Good. Y's on top. Yes! For a Y. YMCA. Y's on top.
Alright, I want you guys to go through the other 4 we didn't do, and then we'll go over those in about 5 or so minutes. So for 19, x was 6. For 20, y was 21. 23, x was 40. And 25, y was negative 30. Anyone need to see any of those the other way it was solved? So again, if you like the proportions and want to keep using that, go for it. If you like the other way and want to keep using that, go for it. If you like both and want to flip-flop, that's fine too. We may have time to do a couple word problems and then be done for today. Somewhere in your notes, you have this page. Okay. I didn't know if it was the next page or not. In general, these rules apply. So for applications of direct variation, one variable goes up, the other variable also goes up. So think about they rise together or they fall together. But for inverse, and we'll talk more about that, I may have actually taken it off of that. So ignore this. It's not there for you guys right there. It'll be back when we do inverse. So that will happen. They'll either rise together or they'll fall together. Also, in all of these word problems, it'll say something that will help you determine whether this is direct variation or not. It'll say something like very directly, like it's telling you which one it is. So that should be a big hint as to how to do this. Right? So I'm going to read this first and then we'll work through this. For number 1, the sales at a baseball game vary directly with the number of people attending. If the sales for a game are 12,000 when 800 people attend, determine how many people attend if the sales for a game are 15,000. Just like we were just doing, finding the missing number, that's really all this is, finding the missing number. That means you have 2 different ways to solve them, either using your proportions or using the other method. So we're going to do one with proportions and one using the other method. If we're using proportions, you need to know what are your y values and what are your x values. So in this case, whatever comes before the words varying directly or varies directly, that's going to be your y value. Whatever comes directly after the words varying directly or varies directly is going to be your x value. So we now know the sales is going to be y, and the number of people attending is now our x. So if we are using proportions, the next part of this, the sales are 12,000, so that would be our y. The number of people attending are 800. So we can set that equal to, in the second part of this, we don't know how many people are attending. That's our x, so that's going to stay x. But we do know that there's 15,000 in sales. So it looks much harder than it really is, but it's really the same thing we were just doing. So now we can cross multiply. I don't know what this is off the top of my head. Someone multiply 800 and 15,000 and tell me what that is. 12 million. Yes. And then if we divide both sides by 12,000, someone tell me what that is. Yes. It's 1,000. Because these are word problems, we need to be specific. These need to have units. 1,000 what? People. So solving it just like we were before, use the proportions, find the missing variable. We're going to do one more, but we're going to solve it the other method just in case that's your preference. And then you'll still have the choice to choose which one you like. Before we do that, do we have any questions on how we solve this, set this up, got this answer? For number 2, really the first part tells you kind of all the information you need to know, the important stuff. So ounces of medication vary directly, there's that word again, tells us what we're doing with the weight of the patient. So with this one, because we are using the other method, trying to do right now, highlighter, yes. We know ounces of medication is going to be our Y. You can also change the variable. So let's say you want to make this M and make the weight of the patient W or P or whatever. You could do that, as long as you keep in mind what it should have been and how to write it. So if I change this to M and W, it's still going to be M, to find K, M over W, or the equation is going to be M equals KW. Or you can leave it as X and Y, whichever one works. However, you need to tell me which one it is. X, Y, M, W, whatever.
Guys, that's a real life good problem to know. You don't want to be taking drugs or pharmaceuticals that don't match up, right?
Yes, that could be a problem if you take the wrong dosage at the
In
wrong
other
weight.
words, you don't want to take 15 pain pills if you weigh about 1,000 pounds. That might be okay. You don't want to do it if you weigh 150.
Okay. So this is our equation. To do it the other method, we're going to take the numbers they give us and we're going to find K. So this would be, Y is our ounces of medication. 3/4 of an ounce. I'm going to use that as a decimal instead of a fraction because then we have fractions within fractions. We know K equals Y over X. I'm just writing this down so we don't forget it. So this would be 0.75 over X is our weight of the patient, and that's 120. Someone put that in your calculator. Tell me what your value of K is.
That's 0.0065.
0.0065. Did I write that correctly? Yeah. A lot of the times with these, unless they're big numbers like the first one, the K value, if you solve it this way, is going to be some sort of decimal. And that's okay. So now that we know our K value, we know our equation is Y equals this decimal, 0.00625 X. And with that last part, we are given the pounds for this patient, 200. That is for X. And we have to find how many ounces this patient would need. So Y equals 0.00625 times 200. Put that in your calculator, tell me what that is. 1.25? And 1.25 what? Ounces. If you really wanted to check yourself, you could solve it this way, go back and solve it using proportions and make sure you got the same answer. Or if you solved it by proportion and then are solving it this way, same thing. Do we have any questions on how we set that up, how we solved that, or got that answer? Once you understand that all of these problems are the same and you're really just doing the same thing, it becomes easier. There are 4 other problems. I want you to pick one of them, do one of them in the next 5 minutes. I'll just show them all, just in case you picked a different one that someone else did. And then if we have more questions on these, we'll go over them next time. But pick one of these 4 and do them. If you get done early and want to do more than that, great. If not, that's okay, but do at least one of them. And then we'll come back and we'll talk about this.
You can't even beat it. I'm gonna be cautious. Yeah, I do what I do.
Okay, so I'm gonna show the answers. I didn't do these, but they should be specific.
So well.
If you did 5, it was asking for K, not anything else. So really, you just need to divide those two. I think same thing for 6. So 10, 750, 32, and 6 were the answers for those. Don't know which one you chose, but for the one you did, does anyone have questions on that one? Again, I didn't do these, and the message here is using proportion, so if you need to see the other one, let me know. So before I let you guys start to pack up, you guys have 4 class academies on this. A lot of it is, can you find the constant K? From an equation, from a graph, from a table, and then can you write the direct variation equation? You guys do not have a delta math on this stuff because there wasn't one available. So those are due on Friday. If you want to go through any of those with me, stay after school or come in the morning and we can go through those. If any of this does not make sense, come see me before or after school. That way we can go through it and get that cleared up. Not on Friday. Also, if you are still missing tests or need to work on retake stuff, come before or after school so you can get that done as soon as possible. Remember that you need to have it done by the 21st, which is next Friday.
I went to the 13 more, I finished all 22.